Hello, in this video, we're going to cover 2.2 of the textbook about limits. So first of all, we'll talk about the definition or how we write limits symbolically, and also explain what it is about. So we want to find out what a particular function is when x approaches a, we will say limit x approaches a when x is a. Then f of x, the function value of x, when x is approaches a from the left side and also from the right side, is equal to L. Okay, so now I do not particularly like these terms equal. So the f of x actually never equal to L because we are only approaching a. X is never equal to a. So let's look at the discussion. This is actually an informal definition of limit. What is a limit? Limit at x equal to a is when f of x approach when x get closer to a, f of x will get closer and closer to a point, to a number L. And then if this exists, if this happen, then we would say the limit exists and is equal to L. So it just describes the fact that f of x actually approach a number, and we would say that is the limit. Okay, so we never plug in x equal to a. And as a matter of fact, x does not need to be equal to a. So numerically, how do we know it? So we would use the method that we did for secant line, estimating the tangent line slope by secant line slope. So we just do a whole bunch of number of the secant line, and then we just estimate. So the important point here is to use numerical estimation of limit by building a tables of values. So we would normally the way we would do would be we'll draw a table. I used to draw it horizontally. Most books do it horizontally, but this book, if you look at the textbook, they do it vertically. So the first is the x value, and this is a, but we never need to do, and this is f of x, okay? But we never need to do this, so shade this out. Don't need to do f of a. We just want to figure out if x, I plug in x equal to a plus 0.1, a plus 0.01, or a plus 0.001. We're getting really close to, oh, should be minus, I think. On the left hand side, let's do minus. Just imagine it's the number line. And this side, at least we would do 6 number. A plus 0.01, 001, a plus 0.01, a plus 0.1. So from this side, the right side, and from the left side, so we will see what these numbers are. Okay, use a table. You can get this from decimal as well as from the TI calculator. See if these agree and see if they approaches a number L, and then this would be the estimate. Okay, so a lot of times these are not a whole number like what we have in the secant line. You would round it to 3 decimal places or 4 decimal places. Okay, so that's the approach of numerical estimation. So let's look at an example. Suppose we have a function of x squared minus 4 over x minus 2. And we want to know when x is equal to a, what would f of x approaches to? Now, if we are doing function substitution, you will notice that this doesn't make sense, right? At x equal to 2, you would have a divide by 0. So x equal to 2 is excluded from the domain. It's not in the domain. But we can do, even if it is not in the domain, any number that is other than 2 is in the domain. So we can actually still calculate the limit of x equal to 2. Because when we find limit, we're just interested how f of x behave when x approaches f of x behave when x approaches 2 from the left and from the right. So we're going to build a table like this. At least do 3 from both sides. From 2, so x would be, oh, I forgot the 2 here. So 2 here, we just don't do anything here. But, oh, I need one more. Maybe I should say here. So 2 minus, so 1.9 minus 0.1, 1.99, 1.999. And then this would be 2.001, 2.01, and 2.1. Okay, so we figure out what f of x is. And you know that decimal is very easy to do. So what was it? F of x is equal to what? A ratio of x squared minus 4 over, oops, we don't need this. Oh gosh. Let's try it again. F of x equal to x squared minus 4 over x minus 2. So this is our f of x, and we want to do a table. So you click on this table will show up. They would tell us, okay, negative, so 1 point, not negative, it's 1.9, right? 1.99, and then 1.999, 2.001. It's very good, getting very close to it. It's 2.01, 2.1. So you can see that at the far end, this is 4.1 and 3.9 is indicating that it's getting closer and closer. So this is a good indication that this will be approaching a limit because they all cluster around 4. It seems like it is 4, right? So let's look at the two closest one. If I round it to 3 decimal places, I cannot see the third one, the 4th decimal place. So I think, how do I make it into more decimal place? I think that's what it is. So maybe let me do a calculator. So I'm not 100% sure that this is good because this doesn't agree. So if I round it to 3 places, so this is not very good. So I will need to do one more. So maybe I'll do 2 points. So this estimate that it is getting closer and closer to a number. So a limit exists. Then if you want to estimate a limit, this 2 has to agree. And if we round to 3 decimal places, this doesn't agree. So we would need to do one more, 1.9999. And then 2.0001. Okay, so if I want to 3 decimal places, this will be 4.000. This would be 3.999. Round up is 4.00. So the estimate is 4. Okay, so you can fill those in. I forgot. The number is 3.9, 3.99, 3.9, 3.99, 3.999, 4.001, 4.01, 4.1. But the real limit is, so L should be, so we should, this is not, in terms of rounding, not equal yet. So we need to do one more term, 1.9999. And 2.0001. So this agree at the limit is equal to 4. Okay, so the second one is 5 to the x minus 1 over x. So that means, and then at x equal to 0, that means if I have a x below 0 and just above 0, what would this function equal to? Now notice x equal to 0 would not work, but we don't care. It's irrelevant. We just want to know what it looked like. And we want to round to 3 decimal places. 5 to the x minus 1. So just change this function to 5 to the x minus 1 over x. Because we're doing 0, so what should we have? 0 point, no, it would be negative, right? Negative 0.0, negative 0.1, negative 0.01, negative 0.001, 0.001 positive side, 0.1, no, 0.01, 0.01, and 0.1. So we click these two first. We don't need them right at this time. So are they getting closer to a number? So it seems like they do get close to 1.6 something, so limit exists. So first of all, look at 6 numbers to see that it exists. But if we want 3 decimal places, they don't agree, right? When they are the closest one don't agree. So we need to do a little bit more. Negative 0.0001 and also 0.0001. Do they agree now? They still not, right? So if I round to 3 places, this will be 1.610. This one is 1.609. So I need to do one more. 0, 0. So if I round to 3 places, do they agree now? 1.609, 1.609. So this would be my limit. Okay, so you would do, I just copy this number, round to 3 places into the notes. Yeah, maybe I'll cut and paste it. So maybe we'll do, no, don't want this. I will just do a cut and paste. Where is my cut and paste? Move it a little bit. It's like getting into the way. Oh, well, okay. So I'm just going to leave it like this so you can copy and paste it into the notes. But that's how you evaluate limit graphically, numerically. Okay, so and then the limit would be, what did we say? When x approach 0, the limit is agree on 1.609. Okay, so the limit is, we would say estimate. So use decimal, right? Estimate equal to L is equal to 1.609 for 3 decimal places. Remember to round it so that they agree on both sides, left and right.